is our next problem. We're going to, again, use the definition of the limit, the epsilon delta definition for this one. Now, we were given the 6 here. So this is limit as x approaches 4 for this function, 4x minus 10. And we can see that when this is close to 4, this will be close to 16, minus 10 is close to 6. And we're going to say that that's our limit, and now we're going to prove it. So what we have to do is this. We have to find a delta greater than 0 such that for any epsilon greater than 0, if we have this condition on x, this is our window, then we'll have this condition on our function, 4x minus 10 minus that 6 will be less than epsilon for any epsilon. So again, on this one, we're going to see what we can do algebraically to transform, and we want to get a handle on this x minus 4 over here. So we have 4x minus 16 from here, which means we have a 4 times an x minus 4. That's convenient for us because that tells us that this would imply this, x minus 4 less than epsilon over 4. So if we were to choose something of this size, epsilon over 4, or less than epsilon over 4, then we could work our way backwards and get back to this statement. So that's what we'll do. We'll choose delta equal to epsilon over 4. And I should add, or smaller. Okay, there's no need to go smaller, but we could if we wanted. We're going to choose it as epsilon over 4. This way, if we have this, so this is actually the proof now, right here. The proof is this: if delta equals epsilon over 4, regardless of the size of epsilon, as long as it's positive, then this should imply this statement. It should imply 4x minus 10. Whoops, x there. 4x minus 10 minus a 6 will be less than epsilon. So let's see if it does. So if delta is equal to this, then if we have this, then we will have this. So let's see if this is true. Start with this. I'm going to drop off that 0. Whoops. If I lost my then there. So I'm going to start with this, x minus 4 less than epsilon over 4. Then I have a 4 times x minus 4 less than epsilon, which means I have a 4x minus 16 less than epsilon, which means, and keep in mind where we're going with it, I have this. So whenever I have this statement, I necessarily have this one, which means the limit must be 6, according to our definition. So I have a little diagram down here that I've constructed. I'll show you what's happening here. This is the f of x is a 4x minus 10. That's the line. And essentially what we're saying is this. This band in here is where x will be. Okay, this band is where x will be. X is somewhere in here. X is less than 4 plus epsilon over 4, and 4 minus epsilon over 4. If that's true, then we're guaranteed that our function value, f of x, will be somewhere in here. Okay, somewhere in here, between the blue, in this blue band. Somewhere between 6 plus epsilon and 6 minus epsilon, regardless of how big epsilon is. So if somebody were trying to, the idea is you sort of play the devil's advocate and shrink epsilon as much as possible. And what that does is it forces this x in here to have a smaller and smaller window. Okay, in other words, this is an interval centered at 4, and x is in that interval, centered at 4, like this. 4 minus epsilon over 4, comma, 4 plus epsilon over 4. Okay, that's in that window. And no matter how epsilon is chosen, I will still always make sure my x fits accordingly so that f of x will be between 6 plus epsilon and 6 minus epsilon. So that's the idea. I can get as close as I need to that number 6 as I want. I just have to shrink epsilon down, which then forces my interval here for x to shrink closer and closer to 4. So if as epsilon shrinks, this interval shrinks and gets down closer and closer to within this interval. But it doesn't say that x can be equal to 4, so just around 4. So that's the idea, graphically, what we're trying to do.